Hello, my name is Simon Tong, and this is my lab report on lab number 1 for Physics 2212. So to start off, a little bit of background about this lab. The purpose of this lab was to show how electric fields interact with each other and how these charged particles can create electric forces on each other. So first, we explored Coulomb's law and its real-world application using everyday items such as Scotch tape, and we visualized how these charges affect each other using a software program called GlowScript. A couple of assumptions we had to make were that the tapes acted as point charges, meaning the electric field originated from one specific point, not the entire length of the tape, and that the only forces on this tape were that of gravity and the electric field from the other charged tape. We also assumed that the mass and charge of the tape is evenly distributed throughout the length of the tape. So into the procedure. The charged piece of tape was created by first laying down a base piece of tape on the table and putting the second piece of tape on top of that base tape and peeling it away. And when we ripped it away, we pulled up electrons from that base piece of tape onto it. We repeated this process twice to make two pieces of charged tapes that repelled each other. We then stuck one piece of tape, one of these charged pieces of tape, onto two columns so it was like suspended in there, kind of like a suspension bridge. And we moved the other charged piece of tape over it so that it was suspended over that first piece of tape. Now, the two electric fields were actually the same, meaning they repelled each other, causing it to actually be suspended. We then recorded the distance between these two pieces of tape just using a ruler, but this was kind of a rough estimate just because we didn't want to touch the pieces of tape and affect the electric field in any way. So on to the data and computations. We first measured the length of the tape and then assumed that it was a uniform mass, like we said before, to find that mass. And that distance between the two pieces of tape is that estimate that we found, that I was talking about in the slide before. Then we calculated the gravitational force on the piece of tape by multiplying the mass of the tape by gravity. And we're able to set the gravitational force equal to the electric force because the tape was in static equilibrium, meaning the net force acting on it was zero. Now you do see those two forces are a little bit off, or a little different, and that's because of possibly the distance between the two tapes not being exact. Now the first question we asked was, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tape and other charged objects? So to answer this question, I said that nothing actually would change if electrons and protons had their charges switched. And this is because positive charges and positive charges would still repel each other, and positive charges and negative charges would still attract each other. And this second question is, why is it important to handle the charged tapes as little as possible? What happens when the charged tape comes into contact with your hand or other objects? And I said it was really important not to touch the charged tapes much because when our hands touch them, they actually will pull some of the free electrons off of that charged tape, decreasing the charge of that tape. This is because electrons transfer from a charged surface to a more neutral object. So onto my GlowScript code. As you can see, this is a visual diagram of what the forces were acting on the charged tape. And as you can see, that top particle right there has two forces, the force of gravity and the electrical force, that are roughly the exact same. And this is what we expect because it was in static equilibrium. So finally, a couple of sources of error. First off, the measurement of distance between the two tapes was not necessarily exact, and this definitely could have caused some error in the experiment. Now, I kind of explained before, this error was generated because we didn't want to affect the electric fields, as affecting the electric fields would have caused even more error in our calculations. The second source of error could have been that the charges on the two tapes were different, and this could have affected it so that the charge of the tape was maybe too small or too large from what we actually calculated. And finally, the final source of error could have been that other forces were actually acting on the tape besides just the gravitational force or the electrical force. Another force acting on the tape could have been air resistance, moving in between those two tapes, or just like wind in the room, or anything like that. So that wraps up my lab report on lab number 1. I hope you enjoyed.